there are dangerous animals. This is what the argument, logical argument. Lions are dangerous animals. There are lions, therefore there are dangerous. Well, our proof start with assumption or the logical notation. So the given lines can be transformed into predicates. Transformed into predicates, and then we can apply the quantifiers. Call two types of quantifiers for all that exists. There are two types of quantifiers that also can be introduced. So let us give a logical framework for the given argument. Lions are dangerous animals, so lions are very important point that we have to note. Dangerous is the another important point here. These two are very important. I mean, these two act as a heart for this argument. So we can, and D of X as X is dangerous animals. So two logical predicates we are making. The one is L of X. X is a lion. Second one, D of X. X is dangerous animals. When we assume like this, we can transform the given statements into logical structures. I read the argument again. Lions are dangerous animals. There are lions. There are dangerous animals. Lions are dangerous animals, meaning for all X, for all lions are dangerous animals. So the first lion or first statement can be written as all X. L of X implies D of X. For all X, if X is a lion, then it is dangerous animal. Now coming to the second statement, there are lines. There exist some lines. So the correct notation is there exists X, L of X. There exists X where X is lines. That's the meaning of the logical notation given to us. There exists X, L of X. There exists X where X is a line. Okay, the premises are these. But what is the conclusion? There are dangerous animals. Therefore, there are dangerous animals. There exists some dangerous animals. There exists dangerous animals. How to transform this? There exists D of X. There exists D of X. So completely converting the statement, lions are dangerous animals, there are lions, therefore they are dangerous animals. We can write for all X, L of X implies D of X. There exists L of X implies conclusion. There exists D of X. Conclusion. There are dangerous animals. There exists X where X is dangerous animal. So we have changed the given statement into a logical structures or logical statements. After changing this, it is possible for us to apply the logical rules called the tautological rules, the equivalence rule, inference rule, everything we can use to prove the inference behinds. Are you ready? We can prove that. When we prove this, you remember, we can use the inference rule. There are two inference rules. Already I told you. First is we can introduce the given premise at any stage. The second rule, we can introduce the logical tautological rule, that is equivalence or inference rule, at any stage if it is possible to derive from the previous steps. We can introduce the tautological rule if it is possible from the previous introduced stages. Okay. Apart from this, another rules are there. That's called universal specification. If a rule is true for universal, then it is true for a specified element. Or if a rule is true for a specified element, then it is true for the universal in the domain. Similarly, there's another rule for a quantifier existence. If for there exists some x which satisfies the rule, then there is rule for a particular element. That's called existential specification. We are specifying a rule which connected to there exists some rule. Then another one is called existential generalization. Existential generalization. If a rule is true for a particular element, it is true for some. It is true for some elements. That is called universal. That's called existential generalization. So these rules we have to use here. So we will start proving that. What we have to prove? Lions are dangerous animals. There are lions. There are dangerous animals. That's what our aim to prove this here. But you must remember that these are English-like, but never equal to logics. But anyhow, to understand the concept, we must take such an understanding. Otherwise, we cannot make a concrete theory on that. That's why we are taking this. Okay, so we will prove now. Two premises are given to us. For all x, L of x implies d of x. And second premise given to us is there exists x, L of x. These two premises are given. With these two premises, we have to prove that there exists x, d of x. There exists x, d of x. Which says that if any tautological rule of the inference theory, here I am taking the left out premise. What is the left out premise? There exists x, L of x. Dear students, you must open the photo I have sent to you before proving this, and on the basis of that only I am explaining here. Okay, so just listening will not help you. You should have that photocopy with you and you have to see that. Okay, come to the proof here. So as a third step, what I am doing is that I am using the first rule in the inference theory. I can introduce a premise at any stage. So the premise for us is there exists L of x. I am introducing now. There exists L of x. There exists x. For that x, it is a line. For there exists some x. For that x is a line. So thus I am getting the third step. Now, there exists L of x. Okay. So now I am going to use the second rule of inference theory, which says that if any tautological formulas can be introduced from the previous step, we can introduce. Now last step I have here is there exists L of x. This is what an existential quantifier. Now there is a rule. What rule says? Existential specification. Existential specification. That says that if a rule is true for some x, then it is true for some particular y in the domain. That is what we say existential specification. So here existence is there. For some x it is true, so I take among them y is one element. Therefore, what I will get is that L of y. The fourth step I will get L of y. From the third step, using existential specification. Existential specification. If a character is true for some x, it is true for a particular y. And that rule I used that to get L of y. And that is step number 4. Now, step number 5, you go back to step number 2. From the logical inference, we know that if A implies B, then it implies B. A implies B, then it implies B. That's what the tautological inference formula. If A implies B, B. Now you come to step number 2. L of y implies D of y. L of y implies D of y. So apply that rule. A implies B implies B. So if you use that rule on step number 2, L of y implies D of y implies D of y. So apply that logical inference rule or logical tautology, you will get D of y. So from the step number 2, using the tautological inference formula, I get the fifth step as D of y. D of y. D of y. Because L of y equals D of y. In the fourth step we have L of y. So L of y implies D of y implies D of y. That's the formula. Logical inference formula says that A, comma, A implies B, then B. A, comma, A implies B, implies B. That is the logical inference formula. Here, from 2, you have L of y equals, implies dy. From the step number 4, you have L of y, which implies D of y. By using step number 2 and tautological rule. Not only step number 2, step number 2 and step number 4, and by using tautological rule. What's that rule? A implies B, comma A implies B, or A, comma A implies B implies B. That formula is used in step number 5. Step number 5. What rules, which steps are used? Step number 2 and step number 4. Thus, I get step number 5. Okay. Now, D of y. What is this? A particular element is dangerous. If y is an animal, it is dangerous. It's a particular element. Now, there is another property or another rule or another principle is there. If an element satisfies a particular property, then there exists some element that satisfies that property. And that rule is called existential generalization. Existential generalization. If a property is true for one element, that property is true for some elements. That's what existential generalization rule says. So, if y is true for D, then there is this sum x which satisfies that D of x. Okay? So in logical notation, we can write there exists x, D of x. I mean, there exists x for which those are dangerous animals. So from the step number 5, we are using the existential generalization rule to get step number 6. The step number 6 is that there exists x for which they are dangerous. There exists x elements, some animals which are dangerous. How that comes? From the previous step number 5. 5 is true for a particular element, a particular animal. Why? That is dangerous. If it is true, then for some x this is true. That means there exists x, D of x. There exists x which are dangerous. Now look at that. We proved. Look at the statement. We proved there exists some x which are dangerous. I mean, there are some dangerous animals. How we proved this? From the premise, all lions are dangerous. There are lions. These are the premises we used. At last we proved that there are dangerous animals. In mathematical or in logical theory, there exists x, D of x. There exists x which is dangerous. So thus, it is possible to prove a logical argument by using a logical inference theory, also tautological rule. Okay, so thank you very much for being with me, and in another class I'll take another one and we will discuss about that. So goodbye, and thank you very much for being with me for the past nearly half an hour. Thank you. Satisfies that property. Dangerous animals. How we proved this? From the premise, all lions